Okay, so in this video, I'm going to talk about the topic on biased wheel. So far, we have assumed that the probability of each outcome is equal to 1 over 38. So the 1 here is referring that the ball landing on a particular pockets in a roulette. And the 38 here is referring that there are 38 pockets. And if you notice that the wheel is equally spaced, so that the probability for landing on one out of the 38 pockets will have the probability of 1 divided by 38. And that is what we have been considering up to this point. And now we are going to talk about a biased wheel, or more specifically, we're focusing on the pocket bias. So in this scenario, we are assuming that the ball is in favor of particular pockets. So here, let me also make an analogy. So for example, we have a wheel that are equally spaced with 4 numbers. So let's call them 1, 2, 3, and 4. So this roulette has 4 pockets here. And then the ball landing on one of the 4 numbers will have a probability of 1 over 4. And this is also the case where we assume that everything is equal probable. So it's just 1 divided by the number of pockets. But now let's consider another case where we also have the same wheel, but the area on this wheel are not equally spaced. So for example, the pockets for the number of 1 has this particular area, and then the pockets for 2, 3, and 4 have these areas. So you will notice that the probability for landing on 1 is equal to 1/2, while the probability for the other number, let's say 2, is equal to the probability for 3 and 4 is equal to 1 over 6. So you can see that we have a pocket that associated with a probability greater than the probability associated with other numbers. So in this case, if you still play the roulette with this wheel, then you will probably have a higher chance on landing on the pocket with number 1, while you have a lower chance for landing in the pocket with the number 2, 3, and 4. So this is an example of a biased wheel. Okay, so we are now going to considering the roulette with a bias associated to a particular pockets. So pocket bias. Okay. So just a comments here is that if players are aware of the bias here, they can exploit such bias. Let's say they can exploit it to eliminate the house advantage. So next we are going to elaborate on what I meant by what I meant here, and also just to remind you that the probability or the expected profit, let's say for a straight up bet, it's equal to 2 over 38, which is a negative number. So that means in long run, we are going to lose money or lose this particular amount for every $1 that we bet on a straight up bet. Okay. But if the wheel is no longer equal or probable, or there's a bias associated to particular pockets, and if we are able to exploit, or let's say we know where is the bias or the particular pockets that are associated with positive bias, then we are able to exploit it and then also to gain or to win money from the casino. Okay. So that is my comment here, and now we are going to see if this is true or not. Okay. So now let's consider the following case. So this is just an example, and then let's considering the following case. So let's consider the wheel, it's positively biased. Let's say toward 3 numbers, and negatively biased toward the rest of 35 pockets here. So the 35 is referring to the 38 minus the 3 numbers. Okay. And let's considering the following 3 numbers. Okay. So the number 2, 4, and 21 happens with probability equal to 0.028. Okay, so here let me also make a comment. 1 over 38 is equal to 0.002631. Okay. So note that 1 over 38 is equal to 0.026315. Okay. Okay, so as you can see that this number is already greater than this number here. So that means rather than an equal probable space, we have this particular 3 pockets that has a greater probability. So you can think of this as in this case, where the ball landing on the particular 3 numbers that we define here will have a greater probability. Okay, so just think about this figure or this kind of wheel for these examples. Okay, so here we have these 3 numbers with probability 0.028, and in this configuration, that means the remaining number have the probability it's equal to the following. So first of all, the probability of everything is going to be 1. And then we need to minus 3 of them has 0.028. So this is the probability for all the remaining number. And then we need to divide it by the rest of the 35 pockets. So you can think of this in this figure. So now we want to calculate the probability for the remaining number. So first of all, the entire space here will have a probability of 1. So when we remove the 1 out of the picture, so 1 minus 1/2, and then we want to equally space. So in our case, we want to equally assign the probability to each of the 3 pockets. So we want to divide it by 3. So that will give us the probability for each of the space here. Okay. So that means the pockets for either 2, 3, and 4 will have a probability of 1/6. So same situation here. So the 3 numbers will have this particular probability. And then we need to use the entire space to minus the probability for those 3 numbers and then equally divide it by 35. So that will give us the number, the probability of, let's say, 1 minus 3 times 0.028 and then divided by 35. So 0.02617. So you can see that when we arbitrarily assign a higher probability to the 3 numbers that we are in favor of, then the remaining number here, for these, we are assuming that they are equal probable for the rest of the 35 pockets. When we divide it by 35, we have a probability of 0.02617, which is less than the number under the equal probable assumption here. Okay, so here this is referring that it's greater than the probability of 1/38, and this is less than the probability of 1/38. So just to summarize here, so previously we have been talking about the probability in the equal probable assumption. So all the pockets, so considering a circle, you divide it by 38 pockets. So each of them will have probability of 1/38. And now we're considering a biased case where some of the number will have a greater probability, and that means the rest of the number has a lower probability. So here you can see that the 1/2 is definitely greater than the 1/4 under the equal probable assumption. And then here, the remaining number will have probably 1/6, that is less than the probability of 1/4, also under the equal probable space. So this is a roulette with 4 pockets here. And now we're going to consider the roulette which still has a 38 pockets, but in favor of, let's say, a specific pockets. So here we're just considering 3 as an examples. And let's say the roulette is in favor of these 3 pockets. And this is we arbitrarily set that these 3 numbers to have 0.028 probability, which is, we set this number because we want to make it greater than the 1/38. And based on that, we also notice that the remaining 35 number will have a lower probability. And this case, and also you can think of a roulette with this particular configuration. And now we are going to analyze the behavior, or specifically the expected profits for this kind of roulette, or in this particular examples. Okay. Okay, so now let's say we notice that, or well, here we arbitrarily set, or we arbitrarily know that there are three numbers that has a higher probability. So let's say we are aware of this kind of a glitch here, and our strategy are the following. So we are going to place a $1 straight up bet for the number of 2, 4, and 21, which we already know that they have a higher probability. So for this kind of a biased wheel, and then we are going to apply this particular strategy to exploit the bias here, and then we want to see whether we can gain money in long run or not. So let's analyzing this particular strategy. So here we are considering the expected profits here. Yes, also here, just recall that the probability, the expected profit for an equal probable, for a unbiased roulette will have a negative expected profit. So now let's calculate the expected profit for a biased wheel. So before we calculate the expected profit, maybe you can now also make a table first. So here, let's have the outcome on the first column. And then we have the probability, the payout, and then the profit. Okay, so the outcomes are 2, 4, and 21. And then we'll have the others. So the probability for landing on these three numbers, each of them has a 0.028, and then we have three of them. So that's the probability for this possible outcome. And the other possible outcome is just 1 minus 0.028 multiplied by 3. That's the remaining, the remaining numbers. Okay. And then also for the straight up bet, the odd ratio is 35 to 1. So here, that means if the ball lands on one of the three numbers, then we will get the 35. Yes, we'll get the $35 because we place $1 for each of the three numbers, and then if the ball lands on one of the number, that means we win, we'll get the 35 based on this ratio here. Okay. And then if the ball land on all the other numbers, that means we won't get any dollar amount values here. So we'll get 0 as a payout. And then for the profit, we will get actually here we also get the $1 that we place on that particular number back here. So we'll get the 35 as profit, and then also the $1 that we originally bet also we'll be able to get that $1 back. So our payout is totally 35 plus 1. Okay. So for the profit is that we need to use the payout minus the cost of entry, because we place $1 for each of the three numbers. So that means our cost of entry is equal to 3. So that means the profit is equal to 33 in the end. Okay, and then for all the other numbers, we will get $0 back, but we will lose the cost of entry. So that means our profit is negative 3. Okay, so here we'll So this will complete our table for all the possible outcomes, probability, and profits. And now we are ready to calculate expected profits here. Okay, so for the losing case, we will have the probability of, we'll have the profit equal to -3 multiplied by the probability for the ball landing on all other numbers. So that is just 1 minus 0.028 multiplied by 3. Okay. And also we need to add the other case, the winning case. So 33 multiplied by 0.028 multiplied by 3. Okay, so now we just need to calculate this particular number. So -3 multiplied by 1 minus 3 times 0.028 plus 33 multiplied by 0.028 multiplied by 3. So as you can see, this number is now a positive number, 0.024, which is greater than 0 and also greater than 2/38. Okay, so here we kind of confirm that for a biased wheel, and let's assume that we are aware of the bias here. And then we also apply the strategy that specifically targeting these numbers. Then we are able to get a positive expected return here, profits here. So that kind of confirm our comments here. So if we are able to aware of the bias, then we can exploit it. So this part is referring to that we apply the strategy. So if we apply the strategy that targeting those particular number with the bias, then we are able to eliminate the house advantage, or in other words, we are able to make profit from the casino. Okay, so that would be the conclusion for this particular examples. Okay, and for this examples is that we are aware of the bias, and more specifically, we know the probability for the 3 numbers that are in favor of. Okay, but right now we are going to ask another question that is different from this scenario, is that how large, maybe let me put an example. Okay, so now let's consider another examples here. So we're going to ask how large. So let's assume that we don't know we know that there are 3 numbers that are in favor of, but we don't know the probability now, because in the previous examples we arbitrarily set the probability for these 3 numbers equal to 0.028. And now let's ask another question: how large the bias the combined bias need to be in order to eliminate the house advantage. So here we know that there are so let's say we know that there are three numbers that are in favor of. But what we don't know is the probability of here I'm just using a dot as like a placeholder for those numbers. So we don't know the probability for those three numbers. So previously is that we assign 0.028 and then we analyze the behavior and we notice that the expected profit greater than 0. And now is that we want to ask what is the number, what is this number should be, or the bias, which is 1 over 38 plus x. So what is this x number? This particular bias needs to be to let the expected profit equal to 0. That is at least break even. So we are not targeting on any particular positive expected profit. We're just going to say that, or we're just going to answer the question, what this x needs to be such that the expected profit is equal to 0. Okay, so this is example 1, and this is example 2, what we are going to do now. Okay, so maybe just put it here. This is example 1, this is example 2. Okay, so now we are going to answer this question. What the value, the x, needs to be such that the expected profit is equal to 0. So this is the break-even case. So exercise example 1 is that we set this number equal to 0.028. We set this number equal to 0.028. We analyze the expected profit. And now the question is, what is the x needs to be such that this is equal to 0? Okay. So with this in mind, let's answer this particular question. So let's clarify some of the notation here. So I'm going to use the letter x for the combined bias. And then there are three numbers that are in favor of. So that means the bias for one of the number is just 1 over 3x here. So you can think of that so first of all, let's start from the equal probable space, so that each number will have a probability 1 over 38, but with some additional bias, and we set the combined bias of the three pockets. So of so the combined bias of the three pockets it's equal to x, so that the bias, so maybe let me put it here. So define the bias for let's say the biased number of the biased pocket is 1/3 multiplied by x. Okay. So the x is the combined bias of 3 pockets in total. And then the bias for a specific pocket is just 1/3 multiplied by x. So you just separate the combined bias into 3 pieces. So 1/3 multiplied by x. Okay. So again, we are interested in the value x here, such that the expected profit equal to 0. So we can again set up the equation from the expected profit here. And so again, the profit for the winning case, $33. You can get it from this table. Multiply by the probability for getting the 3 numbers that are in favor of. So that is the so the probability for getting one of the 3 numbers is 1/38 plus 1/3 multiplied by x. But there are 3 of them, so you also need to further multiply by 3. And this number, or let's simplify this, this is also equal to 3/38 plus x. Okay. So that is the probability for getting the 3 biased pocket. And this is also just referring to the combined bias for the 3 pockets. Okay, and now the profit for getting the remaining numbers is just -3. So let's use a parenthesis to wrap it up. And then also the probability for landing on the remaining number is just 1 minus 3/38 minus x. So this part is coming from 1 minus the probability here. So 1 minus 3/38 plus x, and then you can distribute the minus sign here. You'll get 1 minus 3/38 minus an x. So it's more like the other way around. Okay, so that is how we set up the equation for the expected profit that also involving x, the combined bias for the 3 numbers. So our goal here is to solve the number x. And we are going to solve it by setting this equation equal to 0, as we are interested in how large the x needs to be such that we can break even. So the break even is just referring to this equation equal to 0. So we are going to set this equation equal to 0. So now we have the following equation. So let's write, for now, 33 multiplied by 3/38 plus x. And yeah, so I already multiplied the 3 inside here, minus the 3. So the minus sign is coming from here, multiply by 35/38. This is 1 minus 3/38, and then minus x. So this is the expected profit. We want to solve for x, so that also, so we want to set this equal to 0. So let me write the set. So we set the left hand side equal to the right hand side, and we want to get the number when they break even. So we want to set the right hand side equal to 0. So for the remaining part, it's just solving this particular equation. So we have one equation and one unknown here. So we should be able to get the value for x. So now, just the basic algebra. Let's see. So 99 plus 33x minus 105 over 38 and plus 3x. So the minus 3 multiplied by minus x is a plus 3x. Okay, let's see. 36x minus 6 over 38. So 99 minus 105. So let's change the order. When we move it to the other side, this becomes positive. So x is equal to 6 over 38 multiplied by 1 over 36. Okay, so let's see. So 38 multiplied by 6. 228. So what I'm doing is that I cancel out this equal to 6, and here this is equal to 1. So 1 over 228. And just in decimal, this is equal to 0.00438. Okay, so maybe let's make one intermediate conclusion here. The combined bias let's say needs to be, let me use a fraction for now. To break even, or in other words, the expected profit equal to 0. Okay. So don't forget, this is the combined bias. So if you want to find out the particular probability for one of the pockets, then you can do the following. So 1 over 38 is the equal probability for one of the pocket where they are equally distributed over the 38 pockets. But now you are assuming that there's some bias. So you want to add the bias term, but equally divided by the 3 pockets. And this should be equal to about 0.0277. And for the 1 over 38, 0.0263. Okay, so this is greater than 0.0263. Of course, because you are adding some positive number to the 1 over 38, so you're definitely going to be greater than 1 over 38. So that means the will for some of the pockets, so let's say this is what it used to be, the area in that pocket, and now you are just adding a slightly a bias here to make it larger. So now the ball landing on this particular, or let me, okay. So let's say it used to be this region. So let's say this is the original 1/38. But you are adding, I can add the color. So you are adding one more to increase this region. So adding this bias here. So let's call this one a bias. So the probability for the ball now landing on this particular number, so visually you can see that you have a greater area. So that means the ball will have a greater probability on landing on this particular number. So the bias here is referred for, so the bias for one number of one pocket. Okay, and this is the red part in the figure. Okay, so yeah, but this is just for one particular number, but there are three more numbers. So there are three pockets that has this kind of a bias addition added to it. But in other words, that means for the remaining number, if you still divide it by 35, that means the probability is going to less than the 1/38 case, the 1/38 probability. Let's see, what else do... I think this should be able to cover, and if it still doesn't make sense, then you can think of it as the the 1, 2, 3, 4 for wheels with 4 pockets, and let's make the, let's say 1, 4, and let's make added a bias for 4 here, and then also a bias for 1. So that's the bias for 4, and that's the bias for 1, and these are the region for 2 and 3. So visually, as you can see, you will have a higher chance on getting 1 and getting 4, but you will have a lower chance on getting 2 and 3. So the X here is referring to the combined bias, which is 1/228. And then here we're referring to 3 particular pockets that has this kind of bias. So if you want to calculate the probability for a particular pocket, then you need to divide it by 3, because X is the combined bias for the 3 pockets. Okay, so I think this should conclude our discussion, and then if you still have any question, please feel free to email me.